Alrighty, so today we're going to be looking at a nice word example just to get ourselves a little bit more used to it all. So we're going to be modeling exponential growth. So the value of a particular investment sitting in the bank can be given by v of t, so we're using function notation. V, the value for t, I'm assuming is going to be time, is equal to 10,000 times e to the 0.095 t, where v is the value at any time, t years after the money is deposited. A, determine the initial amount deposited. A, when does initial things happen? Initial things happen when time is equal to 0. So we're looking for v of 0. So v of 0 would be equal to 10,000, times e to the 0.095 times 0. Now, this is really easy to work out. Why? Because this is just 10,000 times e to the 0. And e to the 0 is just 1, so it's just 10,000, because 10,000 times 1 is 10,000. Done. So the initial deposit would have been $10,000. Let's have a look at B. Determine the value of the account after 5 years. Alrighty? So now we're interested in when time equals 5, or V of 5, the value after 5 years. You get 10,000 times e to the 0.095 times 5. Now in this case, a calculator is going to be necessary. And in this case, to two decimal places, we get $16,080 and 14 cents. So after 5 years, the account is going to be worth $16,080 and 14 cents. C, how long to the nearest year would the investment need to be maintained to be able to purchase a $30,000 car outright using only this investment? Alrighty, so you could obviously just chuck in numbers until it gets over there, but we would expect you to use an algebraic method, so let's try that. So in this case, we're interested in when the value, v of t, is equal to 30,000. Well, let's solve for it. 30,000 is equal to 10,000 times e to the 0.095x. Alrighty. First thing I'm going to do is I'm going to move the 10,000 to the left-hand side, so divide both sides by 10,000. 30,000 divided by 10,000 is 3. And now this looks actually a lot more familiar, because how do I get rid of the e? Well, I take the natural log of both sides, the natural log of 3, the natural log of e to the 0.095x. The natural log cancels with the e, and I'm left with ln of 3 is equal to 0.095x. Divide both sides by 0.095, and I get x is equal to the natural log of 3 all over 0.095, which is approximately equal to 11.56 years. When did my t become an x? Oh, way at the beginning. That was my fault. These all should have been t's this whole time. I just get carried away with solving. You always want to solve for x. So the time is equal to 11.56 years. Now, in some cases, you'd want to round down. In some cases, you'd want to round up. In this case, because it's an increasing thing and we want to at least have 30,000, we're going to be rounding up. So that means it's going to take 12 years for us to get $30,000. And there's my final sentence. Alrighty. Thanks for watching, and I'll see you in the next one. Bye.